Dr. Miljana Horvat, Associate Dean, Graduate Studies at the Faculty of Engineering and Architectural Science. Welcome to Operation Breakthrough, Innovations from FEAS, a new initiative from the Office of Social Innovation held in partnership with the Faculty of Engineering and Architectural Science. In this series, we bring together students, researchers, and educators from Ryerson University to share innovations that they have made in response to COVID-19 and societal changes that have occurred. Thank you for joining us today, and we are very happy that you could spare a few minutes of your time to explain about this project. Can I ask you first to introduce yourself, your area of research, and the department that you are coming from?
My name is Sharareh Taghipour. I'm Associate Professor and Canada Researcher in Physical Asset Management at the Department of Mechanical and Industrial Engineering, and as a part of the Faculty of Engineering and Architectural Science. And so my main area of research in reliability modeling, maintenance optimization, and in general physical asset management, and which includes production scheduling.
Hi, thanks for having me. I am Mohammad Reza Bazargan Lari, a postdoctoral research fellow at the Department of Mechanical and Industrial Engineering. I'm working under the supervision of Dr. Taghipour.
As the title implies, like the main idea is that how we can actually come up with the daily planning of the production and the shop floor with the consideration of safety measure related to COVID-19. Means that like we are now currently at the era that we have to follow certain guidelines, and mainly what is important is physical distancing. So we want to do that. So we want to propose a daily schedule of the production. Means that which machines need to process which job daily, but at the same time, we don't want to jeopardize the health and safety of the operators working on the shop floor.
So how did you come up with the idea? Where did you see the need in this for this solution?
Yeah, I mean, currently with the company that we have this Insect Alliance COVID-19, we currently have another Insect Alliance project with the same company. The company is the Axiom Group, and Axiom Group, they are specializing in thermoplastic injection molding for various parts and assemblies. An example is a lightweight fabric. And for the other project, which is not related to COVID-19, we are looking at the real-time production scheduling, mainly in the context of Industry 4. And the main idea there is that in the case of production disruptions, such as machine failure or arrival of a new job, how the production line need to be rescheduled in order to minimize downtime, because like downtimes, even 1 minute incur a huge loss in cost and benefit. And but at the same time, like the objective is to meet the goal, which is meeting the demand of customers. But at the time of COVID-19, we realized that as all the businesses have been impacted, so manufacturing also is no exception. But with the difference is that manufacturing generally is considered an essential work environment, which has never been shut down really. But due to the COVID, that some guidelines have been established by the government and health agencies, and that guidelines came out in May 2020, and they were sector specific. So 90 of them have been for manufacturing process, and those guidelines include guidelines such as physical distancing and sanitation and changes of the production schedule. And this is how we got the idea. So it means that now we are dealing with the same production scheduling, with the same allocation of the job to the machinery, which we not only wanted to maximize benefit, and but at the same time we want to make sure that employer actually, they're considering the health and safety of the operator who are working on a shop floor with a consideration of physical distancing. Means that now physical distancing has been imposed to the problem, the mathematical modeling problem that we want to formulate and solve by that consideration, by that constraint.
What's the innovative part, in your opinion, of this project?
Optimal mission scheduling is not a new topic. However, we are believing that our approach in mitigating the economical adverse effects of applying social distancing is innovative for several reasons. First, this kind of safety guidelines have never been experienced before in manufacturing companies. And secondly, the problem is stem from the design stage of manufacturing companies. In design stage, the designers are trying to minimize the distance between machines as much as possible due to the financial aspects, economical aspects, and nowadays we are forced to distancing machines and workers in order to fulfill the requirements which is published for health. So we are in a challenging situation, and so many companies are facing challenging times since their machines are very heavy and they need some special considerations regarding to their foundation and their connection to the ground. So the layout of the machines are generally is fixed since the machines are fixed in place, and revising the layout of the machines is not practically possible. The third reason is the financial effect that might have this new constraint on manufacturing companies. For example, the owner of the manufacturing companies are really anxious to know the financial effects of different level of social distancing on their net benefits. And for the first time, we have quantified these aspects under productions and net benefits. And finally, we have suggested a soft approach, which is applicable to any manufacturing company. They don't need to revise their machines layout, and using the flexibility of their productions and using alternate machines for producing different kind of parts, they can easily combat with this problem while maintaining the requirements in mitigating the financial effect of their productions. And that's it.
That sounds very exciting, and also it sounds that it may have a long-term impact on many different levels. So how do you see the next steps of this project, or where do you see it going from here?
Actually, in the current state, we have narrowed down to the scope of the problem to a critical zone of a real-world manufacturing company in Toronto area. In near future, we would like to extend the dimension of the problem to consider all the missions in that company.
Thank you so much. This was very nice and very kind of you to clarify and explain more about your project and to giving us your time. Thank you for joining us. To learn more about Operation Breakthrough or to submit your own innovative project related to COVID-19, please visit ryerson.ca/social-innovation/operation-breakthrough. Goodbye for now, and I look forward to seeing you in our next interview.